General Chem classes, welcome to Tuesday. It's December 5th. So a couple things. Today's our last day of notes for the year. So there was much rejoicing about that. So we're going to learn to identify and write formulas for aldehydes and ketones. I told you yesterday, naming gets pretty funky. It gets fun today. Really fun. I like today, maybe because I'm a male. But anyways, quiz tomorrow over branched alkanes and isomers. I have a preview for that as soon as we're done with our notes. And then just a heads up, Unit 4 test will be next Monday, the multiple choice portion. And on Tuesday, the short answer. Okay? So test will be split on 2 days. Multiple choice only on Monday. Short answer only on Tuesday. Quiz tomorrow. And we also have a lab tomorrow. All right? So a couple things. We can take out worksheet alcohols and halocarbons. It was yesterday's worksheet. We're going to go over the last 7 on today because on your quiz tomorrow you have some isomers on the quiz, and I just want to review those a couple different times today. All right. So anyways, once we're done doing that, please turn in worksheet from yesterday, alcohols and halocarbons. And I'll get that graded and back to you next week. And then tonight's homework, aldehydes and ketones. All right. So let's look at last night's homework real quickly. I think right here. So I'm just going to start with number 7. So it says, draw the structural formula for the 2 isomers of butane and name them. Okay. So you're going to have a question like that on the quiz tomorrow. Okay. So butane. But means 4. If I were to write this formula out, C4H10, this is nothing that you need to do yet because I want structural formulas. Okay. So the first thing I would do on a question like this is I would just write it 4 in a row. 1, 2, 3, 4. Okay. I don't care if you put the H's, you can, but you can leave it like that. If I put the H's, they'd look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I wouldn't actually write the H's at the end. Just put lines showing there's an H at the end of each of those. Okay. So that's the first isomer I would draw. And notice it says and name them. So this is butane because it's just 4 carbons in a row. And that is one of my isomers. Okay. The only other isomer I can draw from this, and the easiest way to do isomers is just take a carbon off the end. All right. So I'll kind of show you here. I'm just going to chop this carbon off. So what I have left is 3 carbons. 1, 2, 3. All right. And that other carbon I'm going to put somewhere in the middle because this only has 3 carbons. There's only one middle. So it's going to go right there. Again, if you wanted to put H's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice both of them have 4 C's and 10 H's. That's why they're isomers, same parts. But this one, notice I have a 3-member chain, so that's going to be a propane. And what do I have attached to my propane? I have a 1-carbon chain, so I have a methylpropane. And then where is the methyl on my propane? It happens to be on the 2nd carbon. Okay, so you're going to have something like that tomorrow on your quiz. Butane, 4 in a row, 2-methylpropane, 3 in a row with 1 coming off the 2nd carbon. All right, let's do a couple more. So number 8, draw the structural isomer for two isomers of octane. So again, oct means 8. So my first one, I'm going to do just 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is octane. I'm going to name that. Whoa. I'm going to try to name it octane. Next, I'm going to take one off the end. Is the easiest way to do it. If you want, you can do lots of. I don't know how many isomers of octane are. There's probably 30 correct answers or something. But I'm going to put 7 in a row. 4, 5, 6, 7. And then that methyl I took off the end, I'm going to put it somewhere. Okay, so I'm going to put it here. So notice if I circle, my longest continuous chain is 7. So that is a heptane. I've got a 1 carbon hanging off the bottom, so that's my methylheptane. And then just like naming from last week, which carbon on my chain is my hanger honor? So this is carbon 1, carbon 2, carbon 3. So that methyl happens to be on the 3rd carbon on my heptane chain. Okay. Number 9, draw the structural formula for 3 isomers of pentane. Holy cow. We'll just keep it at 2, all right, because your quiz tomorrow is 2. So pent is 5, so I just do 5 in a row. 1, 2, 3, 4, 5. And I'm going to name that pentane. I'm going to take a carbon off the end, so I have 4 left. 1, 2, 3, 4. I'm going to put it somewhere in the middle, so it'll be right there. I've got, how many in a row? 4. My prefix for 4 is bute, so meth, eth, prop, bute. So I have a butane, and on that butane, I've got a carbon hanger-oner, so that's 1 carbon long, so I have a methyl butane, and where's that methyl? It happens to be on the 2nd carbon, okay? Number 10 and 11, pretty straightforward, I think. We'll do 10 really quickly, all right? And you can do 11 or check with your neighbor and come to an agreement before you turn it in. So all of this is a branched chain, and I want to know if I put all my carbons in a row, what would be just my straight chain alkane, all right? So hex tells me I've got 6 carbons, okay? Meth tells me I've got 1 carbon. So all together, 1 carbon plus 6 carbons equals 7. So if I put 7 in a row, that would just be heptane. Okay, you will not have a question like this on the quiz tomorrow. So anyways, figure out 11 with a neighbor, but we just did 4 of them together. And hopefully these others weren't too bad last night. Okay, so anyways, turn that in and we'll head back to notes. So I will give you a second to take notes out. Certainly the sub can pause it. Feel free to ask the sub to pause if you ever need it paused for notes. All right, so again, worksheet alcohols and halocarbons, make sure that gets turned in. Just throw it in the folder for the proper hour. And we're going to move on. All right. So today we're talking about 2 different types of, organic molecules. So yesterday I introduced you to halocarbons and alcohols. Today we're going to talk about aldehydes and ketones. And there's lots more. We call these families, okay? They have a functional group. There's something that's hanging on them that changes what they are. It changes their boiling points, their melting points, what they smell like, what they look like, all kinds of stuff, all right? Whoa, wrong direction. So aldehydes and ketones both have the carbonyl functional group. So yesterday we found out that alcohols have the hydroxyl group, okay? Aldehydes and ketones both have the carbonyl group. If you want to leave functional out of your notes, you're more than welcome to do so. So both aldehydes and ketones contain the carbonyl group. And a carbonyl is simply a carbon double bonded to an oxygen. So carbon does not equal oxygen. That's what it looks like in parentheses, but carbon double bonded to an oxygen. All right, so there we go. Carbonyl, carbon double bonded to an oxygen. You might not need that in your notes if you have the little C double double O. All right. All right, so an aldehyde has the carbonyl at the end of the chain. And that's probably, that's not probably, that's all you need in your definition. An aldehyde has the carbonyl at the end of the chain. It's always going to be on carbon number 1, okay? Usually it gets written on the far right-hand side, but then we're just going to count the opposite direction, okay? So aldehyde always has carbonyl at the end of the chain. A ketone has the carbonyl somewhere in the middle, okay? So a ketone has the carbonyl somewhere in the middle. So it's impossible to have a ketone until you have 3 carbons, because once you have 3 carbons, you have 1 carbon in the middle, okay? If you have 1 carbon with a carbonyl, that's an aldehyde. If you have 2 of them, that's still an aldehyde. But if we have 3 and we put it in the middle, it's a ketone. If we put it on the outside, it's an aldehyde. So ketone is always in the middle. You might think of a key, like goes in the door. The key's not on the outside of the door. It's like in the middle of the door. It's kind of to one side, but it's in the middle, all right? There's door on both sides of the lock. Alrighty, so aldehyde is at the end, and ketone is in the middle. All right, hopefully you're good. And we're gonna have a slide on aldehydes, we'll have a slide on ketones, do some examples, and that's it for notes today. And then we'll talk about the quiz. All right, so naming aldehydes is as simple as taking the root of the longest chain. So you're going to count up how many carbons you have. What we've been doing for the last week. So aldehydes, we name them by taking the root of the longest chain. So meth, eth, prop, bute, pent, hex, hept, oct, non, dec. And this is great. And we're going to change the suffix to an al. It looks like anal, which is fantastic, because where's the carbonyl on an aldehyde? It is at the end. All right, hopefully there's some people laughing. The end is the anal, yeah, you get it, okay? So we really pronounce it anal, like aldehyde, anal, but it looks like anal, okay? So if the carbonyl is at the end, you've got an aldehyde, and the name of it is gonna end in anal. So the first three, methanol, ethanol, propanol, okay? There's never a number with these because it's always on what we would consider the first carbon. We're usually right at the end, so our carbon on the right becomes carbon number 1. So there's never a number with aldehydes. All right, so methanol is more commonly called formaldehyde, all right? So it's a preserving agent used to in biology, like specimens. We preserve them in formaldehyde, but we found out in the last 50, 60 years that it's slightly carcinogenic, so it causes cancer, so we don't use that anymore to preserve specimens. All right, in naming ketones, we're going to use the longest chain of carbons. And we're going to change the suffix to anone because it's a ketone. So anone, just like anal was an aldehyde. And just like we've been doing, wherever that carbonyl is, wherever that C double bonded O is, we'll use a number to tell us where it is on the chain because now it's somewhere in the middle. All right. So in naming ketones, the suffix anone is used in addition to the carbon number, signifying where the carbonyl is attached, if you want to say that. So maybe 3-pentanone, 2-pentanone, okay? So both are 5 carbons long. The first one would have a C double bonded O on the third carbon. The second one would have a C double bonded O on the second carbon in our 5 carbon chain. Probably the most common ketone that most of you have heard of is acetone. And acetone is 2-propanone. So it's 3 carbons long, and there's a carbonyl, or double bonded O, on the middle carbon. So fairly common ketone is acetone. All right. Lastly, you honestly don't need notes on this. I'm just going to blow through it really quickly. Simplest aldehyde, methanol, is known as formaldehyde. Simplest ketone, propanone, is commonly referred to as acetone. Many aldehydes and ketones have really, really appealing senses things, tastes and fragrances. So vanilla and cinnamon flavorings are natural aldehydes, okay, that occur in nature. They're really, really complicated, like the chain is really complicated with all kinds of stuff coming off of it. But at the end of that chain, you're going to have a C double bonded O, which makes it an aldehyde. So our nose and our taste buds notice and taste and give sensory perceptions to many aldehydes and ketones. All right. So that is it for notes. So we're going to do a few practice things. Let's just come up with a few. So we'll always go from name to formula. So let's say 5-nonanone. All right, so 5 nonanone. So because it starts with nona, okay, I know I have 9 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because it's an anone, I know I'm going to add a C double bonded O. Oh no, where does it go? Oh, it goes on my 5th carbon. So 1, 2, 3, 4, 5. So I'm just going to do a double bonded O going down. You can go up. It really does not matter. Okay, maybe we'll do one of those ones that was in the notes. We'll go 2-pentanone. All right, so again, pent, 5 carbons, 1, 2, 3, 4, 5. It's an anone, so I know I've got a C double bonded O. And where is the C double bonded O? It is on the 2nd carbon, because there's a 2 in front of it, and my 2nd carbon in my chain is that carbon right there. Okay, so that would be how you write ketones. All right, so we're going to go back and I'm going to erase these, and we will do some aldehydes. So I'll erase this one on top first. So again, homework should be straightforward, pretty straightforward, not too difficult. There's the only 2 things on it. All right. All right, so let's go back to my pen. So again, these don't have numbers. So butanal. Mr. Burkett wrote butt anal. Butt anal. Okay, so butanal is the way we would pronounce it. So I'm looking at bute, 4 carbons long. 1, 2, 3, 4. All right, because it ends in anal, I'm going to have my carbonyl group, which is always C double bonded O. That goes at the end, okay? So on this chain, I've got 2 ends. I've got an end on the left, and I've got an end on the right. It doesn't matter where you put it. I'll put it here. If you wanted to, I'll erase this. You could have just as easily have put it over here on this end, okay? So it just goes on the 1st carbon, on one of the ends. All right, real quickly, we're going to go the other way. What do you call that molecule? I'll give you a second to think about it. Little chemistry humor. So we call a laid-back chemist is the name of this compound. A laid-back chemist. All right, hopefully we got it here. So how many carbons in a row do I have? I've got 9, so that's my prefix non, or nana, and I'm going to put an-al at the end. Oh, but if we change the emphasis, we get non-anal, because they're a laid-back chemist. They're not real particular about stuff. So a laid-back chemist would be a non-anal. All right, I'm laughing. Hopefully some of you are laughing with me. Naming organic chemistry becomes lots and lots of fun. All right, one more. And just to show you they can become a little more complicated, I don't think there's any like this on your homework, or if not, there's not much. Okay, so let's say we did a 3-methyl pentanal. All right, so I'm going to start from the right. We always start from the right. So I've got an anal, so I know I have a C double bonded O, and I know it's at one of my ends, okay? I've got a pent, so I'm going to write 5 carbons. 1, 2, 3, 4, 5. And I'm just going to do immediately my pentanal. And then on the 3rd carbon, I'm going to have a methyl group, okay? So methyl means it's 1 carbon long, and where is it? It's on the 3rd carbon. So because I put my aldehyde or my carbonyl here, this is carbon number 1, that's carbon 2, that's carbon 3. So I'm just going to have a line down and then 1 carbon. So this is my meth. This 3 signifies my 3. I've got 5 in a row, and anal tells me I've got a carbonyl at one of the ends. Okay, so homework is on aldehydes and ketones. As you can see, quite a bit of fun. So sub, don't pass out the homework yet. I'm going to talk about tomorrow's quiz real quick. All right, So this is the length of the quiz, okay? This is what nobody's quiz looks like, but it's really, really similar to this. Let me see if I can blow it up. Or actually, let me just see if I can blow up all these writings or all these. Control all. All right, I'll just make it a little bit bigger. So there we go. So write the structural formula for the following 4-ethyl decane. All right. So like I just said, we want to start on the right. So I've got a decane. Notice it ends in ane. So it's just carbons in a row. And dec means 10, just like decade. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I've got a decane there. I have an ethyl, okay? So F is what number? 2, okay? So I need a 2 carbon long chain. Where do I need it? Oh, on carbon number 4. So on carbon number 4, I'm going to go ahead and put C-C. Okay? So that is an ethyl, 2 carbons long, on my 1, 2, 3, 4th carbon in my decane. All right? This next one is interesting, because that's not a word. Let's make it hexane. All right. So 3,3,4 trimethyl hexane. So again, we're going to start on the right-hand side. I've got a hex. So you should know that means 6. 1, 2, 3, 4, 5, 6. All right. So I have methyls, which is 1. So meth, eth, prop, bute. 1, 2, 3, 4. I got methyls. Oh, tri. I've got 3 methyls. So I have 3 branches that are 1 carbon long. So I better have 3 numbers in front of it. So one of my branches is on the 3rd carbon. 1, 2, 3. There's 1 long. Oh, another one's on the 3rd carbon. So I'm just going to go, if I did 1 up, I'm going to do 1 down. And my next one is on my 4th carbon. So there's my 4th carbon. So notice if I numbered these, 1, 2, 3, I've got 2 on the 3rd carbon because I've got 3, 3, and I've got 1 on 4th carbon. Okay. Next, 4-ethyl 3,4-dimethyl nonane. Whoa, there's so much stuff going on. Just take it piece by piece. I wish I had my hand, I would cover up everything but the nonane. Just start with the last word, okay? So pretend put your hand up to your eye, look at the board, and just look at the nonane, okay? So I got a nonane. 9 means 9, or non means 9. So 1, 2, 3, 4, 5, 6, 7, 8. I'm just gonna put it over here. 9. All right. So then I'm gonna move my hand back. Oh, I've got a methyl. Oop, nope, I've got a dimethyl. So I have 2 single carbon long chains, and there's 2 numbers in front of it. So on 3, I'm going to have a methyl, and on 4, I'm also going to have a methyl. And then as I keep on moving my hand back, I've got an ethyl as well. What's an ethyl? It's 2 carbons long. All right, and where is it? It's on carbon 4. So since I've already gone up with my methyl, I'm going to go down for my ethyl, and now I've got an ethyl on 4. I've got a methyl on 4, and I've got a methyl on 3. Okay? So again, we talked about this last week, Monday and Tuesday of last week. So just a little bit of remembering, but most of you are fairly good with this last week. All right. Lastly, on your quiz tomorrow, draw the structural formula and give 2 names for 2 isomers of, and it has the formula. Okay? So unlike your homework where I said butane, you have a formula. So I would start with the obvious one. I'm going to put 8 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8. And what am I going to call that? 8 is oct. So I'm going to call it octane. It's hard to write with this pen, but anyways. All right, so it says draw 2 of them, all right? So 2 isomers of C8H18. So I'm going to take one off the end, just like we started with our notes, and I'm going to make it 7 long and put it somewhere in the middle, all right? So I'll put it there, okay? So I have a heptane, heptane, and I got a methyl group on it, so I've got a methyl heptane, and where is the methyl? It happens to be on the 2nd carbon, so 2-methyl heptane. You are more than welcome to do crazier stuff, all right? So if you wanted to, we could take 2 carbons off the end. Now I've got a hexane, and we could do like a ethyl off this one if I wanted to. Okay, I could be crazy and do 2 methyls and have a dimethyl hexane. All right, so it's limitless almost. It's not really limitless. There's lots of options you can do if I give you something as long as C8H18. I would go with the easy thing, take one off, put it in the middle. Super easy to name that way. But if you want to be creative, you're more than welcome to be creative. All right. So really quickly, let's just summarize. You got homework tonight. The sub can pass that out. Let me go back. Homework due Wednesday. Please turn in today's stuff, alcohols and halocarbons. Quiz tomorrow. We'll start with the quiz, and then we will finish up with the lab. So start with the quiz tomorrow, just so it's out of the way. Lab tomorrow, Unit 4 test Monday and Tuesday next week. Monday will be the multiple choice only. Tuesday will be the short answer only. All right, that is it.